Alright, we're going to begin looking at linear equations. Linear equations. Now they have a definition mathematically that comes from how they're written as expressions. They're equations of two variables. Such that some constant a times the first variable plus some constant b times the second variable equals another constant. A and b do not equal 0. So what we have some amount of x and some amount of y equals a constant number. And we call these linear equations. And we're going to get into why these are called linear equations. But we're going to look at them first as mathematical expressions and find out why they're linear. So let me change color here as I give an example of a linear equation. So this is a linear equation. 2x plus 3y equals 4. We have two variables, x and y. Our constants a and b are not 0. And so this matches the definition of a linear equation. Let's give another example here. Two x equals negative 3y plus 4. Again, two variables, and our constants in front of the variables are not equal to 0. A and b do not equal 0. And so this is what sets up what a linear equation is. Now you should note these are actually the same linear equation, and we tend to have a couple different forms we'll like to see linear equations in. So by convention, there's a standard form and a general form that mathematicians like, and then we have a linear form. We're going to get used to two forms. One is this, where your constants with variables appear on the left-hand side, and they all equal a constant on the right-hand side. We'll also get used to where we have y equal to some expression in x. And we'll play with different forms of this. As they each have useful places. When you do matrix theory, this is really nice for pulling out the components of a matrix. When you're graphing or doing functional forms, this is really nice for how the graphs look like. So being able to translate to the two forms are important. A lot of people tend to focus on one or two forms as they're learning this. And you need to keep in mind that you want to be flexible with the different forms. So we have solutions now for linear equations where if we have 2x plus 3y equals 4, we get multiple answers. I could have x equals 2 and y equals 0. I could also have y equals 2 and x equals -1. Notice we get a pair of numbers with each solution. And these solutions solve and keep this statement true. So a solution for a linear equation is a pair of numbers. And we'll write that x comma y in parentheses. We call this a coordinate pair also. A solution set. Or an ordered pair. Now, coordinate pair we'll go into when we start using Descartes' system of organizing things. And solution set is a more general way of saying it. I think for what we're doing here, you'll hear ordered pair said a lot because it's a pair of numbers in an order, x, comma, y, ordered pair. Ordered pairs are infinite. You can have as many of these as you want. And for each x value, you get a y value. So what you do to check your ordered pairs is you plug them in. So if I look at the first ordered pair I have here, when I did this, that gave me the, I'll make it orange here. Let's make it orange. So this is my first ordered pair. I had an x value of 2 and a y value of 0. Well, to check that, I'm going to plug into my original equation up here. 2 times my x value plus 3 times my y value equals 4. So I get 4 plus 0 equals 4. 4 equals 4. And so this is a good ordered pair. When I look at the other value, let's change this to red. It's red show up, yeah, good. Of -1, comma 2. So I'm going to use this equation again, and I check 2 times -1 plus 3 times 2 equals 4. Plugging in my x value and my y value from the ordered pair. So 2 times -1 is -2, plus 3 times 2 is 6. 6 plus -2 is 4. And so this is a good ordered pair. So what we can do is we can actually construct ordered pairs by finding values that are easy to solve. And a lot of what we first do when working with two variable equations is we play with different numbers to see what ordered pairs would be able to work. And we're going to look at some specific examples of ordered pairs in the next video. But our idea here is when we have two variables, our solutions come in a pair of numbers. Two variables, we get a pair of numbers, and we'll always write them in the same order. The x variable, comma, the y variable. Now, as you progress in mathematics, you won't always have x and y as variables, but we're going to limit things to x and y for now so that we're consistent in the patterns that we see coming out and how we set this up to be graphical.